Hello, welcome back. So, if you've been watching the post you see on my YouTube channel, should recognize this screenshot here. Basically, we have a view of the sunset over water, and you can see balloons kind of popping out of the water. We have the ripples forming wherever a balloon pops out. We have a reflection in the water as the balloon rises in the air. You can see that further out in the distance, the balloons are smaller. And basically wanted to walk you all through how I built this little demo. You can see balloons periodically show up. If you click somewhere, it'll spawn a balloon in that position. The Mini Micro has no access to 3D hardware, so it begs the question, how do you get something like this working with only whatever 2D pixel-based capabilities you have on hand? And so, let's walk through how this is built. First of all, I'm going to create a new file here. Let's call this one. I'll just open the editor. And I'm going to call it ripples. First of all, let's talk about how to set the basic event loop. There's a set of imports I'm going to have almost every single time with the little graphics demo. The import util gives us access to the ensure import function. The ensure import makes sure that basically each of these packages is a singleton. Events will only be imported once. If you do an ensure import for the events package in another file, it'll refer back to that very same events object. Without that, you could end up with two different instances of your events object floating around, and everything gets weird. List util gives us some extension methods off of lists. Like if you wanted to remove an object by value instead of index, it's really useful. Math util gives us a couple of things like a min-max functions. And TC is kind of special. It stands for tweet code. And it's not entirely related to what I'm doing here. Basically, a tweet code is basically a self-imposed competition. Try to write an interesting program in 280 characters or less. The TC package gives access to a lot of functions that support that. Shorter names for different graphics functions. Way to do page flipping with one command. So it's for little graphics demos, it's really useful. And then, so we're going to start by drawing the background. Let's take that back. We're going to start with our event loop. So to get the event loop started, one of the very last things you want to do, events, event loop, run. And let's see. At the very, very least, to run an event loop, you're going to want an onUpdate function. I'm going to show you that this is working. Every time the event loop runs, we're going to print tick to the screen. So run that. That's about how it works. It's actually more interesting if we have it print the frame in there. So that way you can see about how often it's updating over time. Even more interesting if we update the frame count on each frame. What did I do there? Oh, global variables. If you're going to assign something, which a plus equals operator does, you need to make sure you're referring to a global variable. Otherwise, it's going to try to increment a local variable that does not exist. You can reference global variable just fine, but assignment, you gotta stick the global dot in there. There you go. So we're updating about that fast. I think it's aiming for about 60 frames per second. Control C to get out. Edit to get back in in our editor. So we have our event loop. All right, let's begin getting something on the screen. First of all, when you're drawing to the screen, first thing you want to do, generally, clear the screen. In this case, we're just going to clear it to a clear color. CLR is an alias in the TC package for the gfx.clear, which clears the graphics screen. And then we want to draw a couple of pictures on the screen. Going to be working with a couple of different displays here. So we cleared the text screen. We're also going to have a background, which is a pixel display. We're installing it on display 7, which is the very back. Normally it's a solid color display. We want it to be a pixel display so we can draw on it. And because here we'll no, we'll just keep going. You'll make a little more sense in a few minutes. So creating the background, scrolling through my notes here. The background is going to receive the picture of our water. And that's just going to stay there the entire time, untouched. And to draw the water, we are going to need, you see there's a display background, which is what we just created. I'm going to draw an image. The image is going to come from a generate water function that we don't have in place yet. And the last two parameters here are the x and y value, which in this case refers to the bottom left of the screen. So the generate water function, we're going to stick up here. And it relies on a couple things. Basically, what's happening here, we are drawing our water image to an off-screen display, and then getting the image from that display and returning that image. This is how you dynamically generate images. It's relying on a couple things here that are still undefined. We have the height of the water, which is how far up from the bottom of the screen does the water go. We want it to go about a third of the way up the screen. It also relies on this watercolors. That's our palette of colors that we're using to color the water. So let's grab those bits. The water height is defined as the graphics screen height divided by 3. So it goes a third of the way up the screen. And then we have the watercolors. And that's our palette. I got this list of colors. Just do a Google search, sunset over water palette. It'll give you a list of HTML colors. I got the 5 colors here, and then finally the orange color, which is when you're doing a linear interpolation between colors. Like the very bottom of the screen will be this dark color. It'll get brighter and brighter and brighter. And then right at the horizon line, we're going to have it fade into this final orange color. And let's see, background, draw image. That should be enough to get the background on the screen. Let's find out. Keyword not found, text, line 44. Oh, it's because that's display.text. One thing I forgot to stick in there is our reference to the display map. Display map like this is not strictly necessary, and in fact, it blows away the built-in display map. This is like there's actually a class called display, but I just find it easier to refer to as display.text or display.sprite when I'm throwing code around. Okay. And you can see the generate water function. If you can see, well, basically it does a linear interpolation between our 5 colors all the way up to when it gets to a third of the way up the screen and then fades into orange. Control C to get out. And you can see it's basically range from 0 to watercolor's length -2, which means the length would be whatever index is here. It's like 1, 0, 1, 2, 3, 4, 5. But you want the last iteration of the loop to go through the length -1, 2. That's the final color. So that one's going to interpolate between that color and the orange color. And then for each of those, it breaks up the entire height of the water into sections according to how many colors we're interpolating between. And then for that entire section, it draws a line, calculate the color based off of what percentage of the way are we into that section. You see the delta y divided by section size will give us a percentage. Pen size equals 2. The line, like we're going up one line at a time, doing a pen size of 2, make sure that if we made any mistakes that the lines would overlap each other and the whole space will still be filled up. So it's sort of a error checking mechanism. That's our background. That's just kind of set. And then we're going to draw the sunset up top. So for the sunset, up in the sky, we have a list of sunset colors. It's the same list of colors, but instead of going from dark up to bright orange, it's starting at a bright color at the center of the screen and then fading to black at the very top. I need to find a shortcut for that. Anyway, so we have the sunset colors. We similarly are, let's see, the height of the sky. There's the height of the entire display minus the height of the water. So it's basically the remainder of the height, which is going to be just the top 2/3 of the screen. But we're doing the subtractions. We could have done like GX height times 2/3 to get the 2/3, but then you're going to be at risk of some percentage errors. Dividing by 3 is not easy for a computer. And then let's draw our sky. Just like we have a generate water function, we also have a generate sunset function, which does something similar. We're dividing the sky into sections. Each section is the same size. Iterate over our list of colors, and then for each color, iterate over the whole section and draw a line for whatever color we're needing there. Return that image. Now the image is starting, like the bottom Y value is right where the water ends. So we want to grab from there up to the top of the screen. And that's our image. And then we need to render that. This one, it's like for the background, we're just going to draw it once and be done. For the sunset, we are going to actually draw it inside of our event loop. I have a comment there. Redrawing the sky overwrites any ripples that went out of bounds. Basically, the water is going to be rippling, which is going to be sending ripples outwards toward the edge of the screen. If for some reason the rendering of that ripple overflows the edge of the water, we don't want ripples flying through the sky. That would just look weird. So we're going to make sure that when we're done drawing everything else, we then redraw our sky and then flip as we're doing double buffering. We have we're always drawing to an off-screen display, finish drawing, and then flip the off-screen display with the on-screen display, which the benefit there is that you don't see any sort of weird side effects of like the whoever's running your program won't see that you're drawing. They'll just see that the image suddenly appears. So let's take a look at where we're at. Sunset image is unknown. Line 74. We actually need to calculate that image. Let's do that. Sunset image equals generate sunset. There we go. We have the water and we have the sunset. Make sure that I'm doing what I want to do because that something doesn't look quite right. Oh, I forgot a bit. So the problem is we're using the exact same colors for the sunset and the water. But that's not normally how water works. Water usually has its own kind of color going on that modifies whatever's in the sky. It's like when you're looking at the ocean, it doesn't usually look as blue as the sky. So what we're going to do to fix that is have a base watercolor that we're averaging all of those with, which is going to work kind of like that. We're going to iterate through all of our colors and then modify that color. Take it 50% of the way from whatever the color was to a dark blue. This is a HTML color, so first two numbers are red, then green, then blue. 8 goes from 0 through F because it's hexadecimal. And 8, so 88 is kind of a dark blue. Looking at that now, you can see that the water kind of looks the same as the sunset, but moving towards more of a blue. So it looks a little bit more like water. Now let's get something into that water. I'm going to start by plopping our... I'm trying to see, do I want to start with the ripples or the balloons? Ripples or balloons? The ripples are actually easier to implement. We're still going to need a pile of things here. Let's see. First of all is we want to respond to a couple of events, input events, which I'm going to paste in there now. In our frame counter. So we have two events. We're responding to the escape key on key down. If that happens, stop the event loop, kill the program. On click, it's responding to a mouse press. If the mouse button 0 was pressed, then check to see is the Y value inside of the water area. So basically, that's the same as water height. And we're not ready to generate balloons yet. We'll get there in a minute. And let's print X and Y values. X is unknown because it's not called X, it's called Rx. There you go. Every time you click, you have an X and Y value, but if you try to click the sky, nothing happens. The Y value has to be less than, like between 0 and the height of the water. And the escape kills it. And ultimately, we're going to want to generate balloons when that happens. So let's take a look at that function. But function is ultimately going to take 3 parameters, x, y, and c is the color. I'm having them default to null for reasons we're going to get into soon. So what I want to be able to do is make a ripple on the screen. And the way that works There's actually a big chunk of code here in order to make this happen. We're going to walk through it pretty quickly. So what's happening here? We calculate number of ripples. We get a random number between 0 and 1, multiply by 5, so now we have a floating point number between 0 and 5. Get the floor of that, so now we're only looking at integers between 0 and 5, and add 1. So that makes sure that's between like 1 and 5, basically. More or less. We have a base delay and a delta delay, which is going to be an offset for each delay. It's going to be a somewhat random number. We have a chance of making between 1 and 5 ripples when you click. And what's going to happen, we don't generate it right away. We use the do after command. This tells the event loop to wait for a delayed number of seconds and then launch that function, the make ripple. And then the next ripple is going to have even more of a delay because of the delay delta. And then each time it executes do after, it'll call make ripple, which will then make a new ripple and add it to our ripples array, neither of which we have created yet. So let's go ahead and create those. We need an array to hold our water ripples, like so. And then we also need the ripple class, that one. And stick it here, talk through it pretty quick. The source code will be available if you want to review it more in depth, or you're always welcome to ask a question down in the comments and I will get back. I will get an answer to you. So here's our ripple class. We start by creating a new map, have an init function that initializes the map, create a ripple at this x and y value, give it various properties, pen sizes, how thick the lines are, the speed of expansion for the ripple. Is it currently alive? Like ripples will fade down to transparent and then they should fall off the array. The scale, ripples are bigger if they're closer to the bottom of the screen. As they fade into the distance, you want ripples to get smaller. And then this at the size, color, and offset, the two colors fade as the ripple gets bigger. That's needing a couple more constants in here. I'm just going to grab all of those now. We are now ready for the big constant value reveal. Massive speed multiplier because you want everything to be every time you do an update, you want it to be based off of the delta time since the last frame update. And in this case, I had to multiply that delta by 100,000 to make the speed look right. Base size, watercolor, the ripple color is going to be white, and then the ripple offset color is going to be basically... I'll explain the ripple offset in just a minute. There's the ripple make function. Create a new ripple, initialize it, return it. Some properties that we need to work with. We can get the width based on the size. The height is that same size, like the width divided by 2 times the scale. Like the width won't change as you go into the distance, but the height, it'll basically shrink. And then the TC library provides the oval function, which allows us to draw 2 ovals on the screen based off of the left, bottom, width, and height parameters that you can see here. And the pen size, color and pen size. So we're going to be drawing a ripple, which is white, fading to transparent, and an offset color, which is it kind of provides a wave effect, making it look like it's traveling through water. Every time we update, we're going to have a scale, modifying the scale, modifying the color. And a whole pile of math here to update the size and scale to linearly interpolate the color down to transparent. If any of the components color components go from 0 to 255. If they fall below 1 for any of those components, then basically the ripple is dead. we need to mark it as dead to remove it from the list. So if we ran it now, it should run, but it doesn't draw any ripples because we didn't add any drawing functions to our event on update. So first of all, we don't need to print out the X and Y anymore. You got the point there, I hope. We're going to modify the onUpdate loop. OnUpdate, where did I put you? So we're iterating through the ripples, update the ripple. If it's still alive, stick it on our list of live ripples, and then draw it. And then we take all of our live ripples and write it back to the global ripples array. So anything that's dead is just going to fall off the list at the end of the onUpdate function. That should be enough to get the ripples on the screen. Let's find out. Yeah, there we go. You know, they're pretty snappy. Sometimes when you click, it'll generate one. Sometimes it generates a whole series of them. The idea is that it doesn't have to be like completely physically accurate. It just has to look real enough. That's a trick with computer graphics. You want it to look real enough. If you make it look too real, you get into that thing called the uncanny valley, where it's like it'll just look weird because you can tell it's almost realistic but not quite. And then it's like they call it the uncanny valley because a lot of people find it disturbing when things are almost completely real but not quite enough to fool you. Next, we're going to draw balloons. Every time we click somewhere, we want it to put a balloon on the screen. We're going to need an array for balloons. We're going to manage balloons very similarly to how we manage ripples. We're going to draw the First, we draw the ripples over the background image, and then we redraw the sunset to make sure any ripple overflow is erased. And then we're going to draw our balloons. Now be the last bit of the update loop. It's the same type of thing. Get our live balloons array, go through our balloons in reverse. I'm actually not sure if this part's required anymore, but I'm gonna leave it for now. It was to make sure that we're drawing back to front so that the balloons that are farther away look like they're behind the balloons in the very front. But we update the balloon. If it's alive, we keep it. If it's not alive, we clean it up. This is because, and we're not drawing it, because what's happening is rather than drawing pixels, the balloons are being pushed into a sprite display. The sprite display maintains an array of sprites, and all the drawing is handled automatically. Drawing sprites is actually a lot faster than drawing pixels. The architecture of the Mini Micro it's actually kind of similar to what you might see if you were programming an old 8-bit Nintendo. It's like, if you're programming for a Nintendo, the original Nintendo, you don't render sprites pixel by pixel. You basically have sprite images sitting in memory, and then there's another chip alongside the 6502 inside the old NES that would pull sprites from sprite memory and handle all the rendering and updating of sprites for you. So it's like all the sprite processing was offloaded to another processor, which is actually pretty cool. But the point is it's automatic and it's fast. So you should try to use it if you can. In our generate balloon, so now that we're generating ripples there, we also want to generate balloons in our generate balloon function. And for that, it's actually a lot simpler. We don't want to generate like a random number of balloons. We just want to make one balloon. So we make a balloon, X, Y, C. So we're grabbing that color. And then we sort our balloons array by the Y value. Like every balloon has an X and Y property. We want to sort the balloons by the Y property. Oh. Actually, It's actually a lot more efficient to only reverse your array once when you make a new balloon than to do it on every on update. So if we need to do it at all, it should probably be done here. You want to sort your array as little as possible. Now, the C, the color, is going to be null. We're only throwing in the X and Y values. So we need to calculate a color. How do we want to do that? Oh, yes, I remember how I handled this. Okay, we're going to ignore this for now. We're going to pass a null color into our balloon make function. Which is going to make sense in just a second. Drawing with null color, that'll make it invisible, right? Copying and pasting our balloon function. Now, I'm going to explain what's going on here. We have the speed of the balloon. We're going to use the same speed multiplier as our ripples, and just like base the speed of everything else off of that, off of a global speed multiplier. It helps keep things consistent. Creating our balloon definition as an initialize function and a make function, just like everything else. The make function creates the new balloon, initializes it, passing in the x, y, z color values, and then returns a new instance. So treat the make function as sort of a static function. Initial init is like the actual constructor where it has a sense of self. Saving where it started, that is alive. It has an initial height. The initial y is used to. I'm doing some complicated math. It's not that complicated. It just took me a while to figure out to manage the fact that as a balloon is rising from out of the water, we wanted to draw a partial image until the balloon is done rising. If C is null, we grab a random color. So we're going to have to get that random color function. The 192 is the alpha value. So we want it to be the balloon to look a little bit transparent, just like a real balloon. And then we have a sprite and a reflected sprite. We have a sprite for the balloon that's going as it rises up. It's being pushed into our sprites away. The reflected sprite is going to have the same color as the balloon, but the tint. We're going to get the index 3 is like that tint array. When you convert a color to a list, it's RGB alpha. Alpha value, we're going to divide by 2, so it's going to look fairly transparent. We're going to rotate it 180 degrees so that so it actually looks like a reflected image. Then also push that onto the sprite array. Now, before we move on, let me grab the color data and that balloon image constant. We're making use of a TC function that is going to load an image based off of name. It looks in a couple of different places for a file with that name .png. If you don't supply an extension, it assumes you're trying to load a PNG file, which I think is a pretty good idea. I actually went up here with the other constants. And then there is also the random color generator. Random color. The way that works, I'm going to stick it up here. We have our array of colors. Basically, the color map has a bunch of different color definitions. And then your random value times colors.length, floor that to turn it into an integer, and then convert that color from a HTML color into a list so we can modify the value, convert it back into an HTML color, return it. That's your random color in HTML. So that creates a balloon which is composed of several properties and 2 sprites for the balloon going up and the reflected balloon going down. Some math to update the position. And there you go. We have balloons. Performance works pretty well. I think you can get like 20 balloons on here before you start noticing a huge performance penalty. The final thing we want to add here is a little something to make balloons just show up. We're going to make use of the do after function. After 0 seconds, generate a balloon. The effect of that, if we go back to our generate balloon function, it's going to pass x null for all these parameters. What we want to do, if everything is null, then we need to calculate something reasonable. Like, for example, if x and y are null, we want to pick a random x and y value that is inside the area of the water being rendered. And also, we want to queue up the generation of another balloon. So every time it generates a balloon, it queues up an action to generate another balloon, so that it'll basically generate balloons forever. And let's go ahead and run that. Here. Clear, run, and there we go. And it's kind of nice to watch, and it will just generate balloons forever. It's a nice screensaver. It's not perfect, it's pretty close. So I'm going to be uploading this to my itch.io account. The link to that will be posted along with this video. And coming up soon, I'm going to be showing you how to put this whole thing to music. Use the balloon generator as sort of basically a music visualizer, which is going to be a lot of fun. And thanks for watching. Let me know if you have any questions. I will be around.